Okay. Okay. Thank you, everyone. First of all, thank you for the Pycon organizer for giving me this opportunity. So it's truly been honored to be here, and also thank you for you all, the audience, that attending session and being here today with me. So this is my first time speaking at Python. So I'm super excited to share my experience with Python with this community. Okay, without further ado, let's start the session. We start from this platform. I believe most of you know this platform, the platform where we search for the job or we get an offer from an job offer from another company. And also, you may know that LinkedIn has more than 950 million users around the world. And from those users, LinkedIn need to process 4,000 trillion real-time events in a day across their 3,000 pipelines. So the question is, how LinkedIn handle such kind of big traffic in their infrastructure? So the answer is LinkedIn uses Apache Beam. So by utilizing Apache Beam, LinkedIn gets several benefits. The first one is LinkedIn now has the unified streaming and batch processing pipeline, which improve their cost optimization by 2 times and also improve the performance by 2 times as well. And for their anti-abuse platform also is improved by 6% for detecting login scraping, login profile scraping. And now LinkedIn has the platform for generating machine learning features in real time, improving from the pipeline for 24 to 48 hours delay for generating the ML pipeline, the ML features. And lastly, by using Beam, LinkedIn now can build their own managed streaming processing platform that improve their pipeline deployment from months to days. So that's the huge advantages of using Apache Beam. So from this use case, I'm interested to share to you about the Apache Beam in today's session, especially for building the streaming pipeline using Apache Beam. So, okay, I'm Bima. I'm a machine learning engineer, and yeah, this is my contact. And by the end of the session, I hope you can find that building the streaming pipeline using Apache Beam is very easy. Okay, before come to the concept of Apache Beam, we have to review several basic concepts. We start from the data. So we have two types of data, bounded data and unbounded data. Bounded data basically is a data that has a fixed size. You know the start and the end of the data. The data is already completed. The bounded data is best for batch processing. And the example of bounded data is maybe your CSV files, your Excel files, or even your tables in the database. On the other hand, unbounded data is the data that continuously generate data. You will not get the start point and the end point. And then the unbounded data is best for the streaming pipeline, yeah, because streaming the continuous data. And also the device, for example, or the user action on the website or in the company's website, something like that. And from this concept, I mentioned two other concepts: batch processing and streaming processing. So, what are they? Batch processing is the system to process all data at once. So that's why batch processing requires the data to be completed first. The usage of batch processing usually is to generating the EOD report, for example, or analyzing the historical. And streaming processing is, however, designed to process the data as it arrives. So the streaming processing will process your data as soon as possible after the data is coming to your system. So streaming processing pipeline is crucial for the application like fraud detection or real-time monitoring, because in fraud detection you want to catch the fraudster as soon as possible when we detect the fraudulent activity, right? Okay, so the another question is, before Apache Beam, is there any way to deploy, to build a batch processing system and stream processing system in our production environment? The answer is yes. You may know one concept called Lambda architecture. So Lambda architecture is the concept that has two components in the processing the system. So there are two components which are the base layer for the batch processing pipeline, usually using Apache Hadoop as a framework, and then speed layer for the streaming pipeline, usually using Spark streaming as the framework. So from this architecture, you may find out the drawbacks. So drawbacks is we have to maintain two components, meaning we have to maintain two code bases. Maintaining two different code bases gives us some complexities. So and then instead of like developing two different pipeline with two different framework, why not use a single framework that can do both batch and streaming? So that's where the Apache Beam comes in. So by definition, Apache Beam is an open source unified programming model that enables users to define both batch and streaming data processing pipeline. So if we go back to the Lambda architecture and we revise the architecture with Apache Beam, so we can get the new architecture similar like this. So instead of having two different components for batch and for streaming, we can replace with a single component called Apache Beam. So that's the main benefit of using Apache Beam. And another interesting benefit or fact that Apache Beam offers to us is the flexibility. Uh, by mean that you can execute Apache Beam code on multiple runners. So if you have the Apache Flink runner on your production environment, you can run the Apache Beam on top of the Apache Flink runner. Similarly, you can run Apache Beam on Cloud Dataflow or Apache Spark runner, or even you can use a Beam direct runner to run your Apache Beam in your local machine or in your laptop for testing and development purposes. Okay, so this is the snippet code to show you how easy we switch between streaming mode and batch mode. So if you want to make your Apache Beam code to be a streaming mode, you can make sure that the streaming value under the standard option is true. So the Apache Beam will get the data from the streaming sources like PubSub. On the other hand, if you want to switch to the batch mode, you can go to the other block, to the else block, and then specify the bounded sources like tables or files, and then Apache Beam will run as in the batch mode. You don't have to worry to change the logic of your ETL because the logic will remain the same. You only have to constantly change the source of the data. Okay, so now we come to the concept of Apache Beam. There are three main concepts of Apache Beam: P collection, P transform, and Padu. So, yeah, and then start with the first two concepts: P collection and P transform. P collection is basically your data set. P collection contains your data, and P collection is immutable, meaning after the P collection is created, you cannot change the value. If you want to change the value, you have to create a new P collection and transfer the value from the old P collection to the new P collection with some operation. And P collection can store any data types. So that's makes the packaging flexible. On the other hand, the P transform is the operation or transformation logic that you want to apply to your collection, to your data. And at the bottom one is the common flow of your pipeline you may build later. So you have one P transform to read the data from the source and generating the P collection. So we call it P transform one and return the P collection one. P collection one will be consumed by the P transform two and implement your transformation logic, your application logic, and return the new P collection called P collection two, and so on and so forth until you get the end of the pipeline, which is you have the P transform to store your result, your transformation data into the destination storage. Okay, so from that those two concepts, we can generalize the structure of the Apache Beam code. Basically, we have three main steps. So read data from the source, and then transforming the data using the P transform, and then we write the data to the output, to the destination storage. Okay, now let's talk about the Padu. So Padu is the most important component in Apache Beam. Yeah, because Padu is basically a custom function that contains your custom logic that cannot be done by the built-in P transform from Apache Beam. So how does Padu work? Padu process everything in parallel, meaning your data will spread out into n Padu instances, and it will be executed in parallel together. So your data will spread out, and then each result will be collected into the P collection, and then the Padu will return a single P collection again. And one tip when you're working with Padu is don't forget to enclose your result to using square bracket to make it a list. Because if not, your output will be get iterated over as an individual element. For example, if you have one string, if you don't enclose with the square bracket, your individual character will be spread out instead of the full string. So it could be work for your content. Okay, so that's the example of the Barbie for the custom function. And then there are the key features of Barbie. The first one, element wise. Barbie will process element by element, and then you can output the flexible output. You can return any form of output, and it supports the set inputs, meaning you can pull the external data within your Barbie instance. Okay, for the branching also, Apache Doom support for branching. So you can split your process based on the same data into several branches. And it's very easy in terms of the code, the syntax. Okay, we come to the windowing. Windowing is also the important concept in streaming because basically in streaming context, we are dealing with potentially infinite data. So if we want to process the data, if we want to wait the data until it is complete, yeah, it never been happened because the data is continuously generated without ending, not endless. So we need to window to chunks the data into manageable window or chunk so we can process the data efficiently. So there are three types of windowing. The fixed windowing, which is to have the equally size of window, and the sliding window you can have the fixed window and then the sliding way, so you can have the overlapping window, and then the last is the session window, which is the window that based on the activity of the data, and then if there is a gap of inactivity, the window is automatically closed, and then it will be processed to the next step. Okay, so for installation, it's very easy. You can install the Apache Beam, like you install the other libraries using Pip, Apache Beam, or if you want to add additional plugins to deploy your pipeline into cloud environment, for example, like GCP, you can install the Apache Beam with the additional plugins, with the Square, Bucket, and GCP. And for running Apache Beam locally, it's also very easy. You can use the command line Python beam.py, just run the runner. It will run your pipeline in your laptop, but make sure that you have to put the argument parser inside your Python code so that the command line can work properly. Okay, so now come to demo. So I want to show you how to do the aggregation and the join operation using GCP. Um, okay, let's see. So basically, this yeah, I get the data from the PubSub, and PubSub will return the data as a byte. So I need to decode first using JSON.log to make it a dictionary, and then I create the pair, the key value pairs in form of a tuple, and then I have a fixed window by 10 seconds, and I put the sum aggregation function by using the built-in key transform combine per key, and then show the data. Let's begin the segment. Okay, so I put okay. Okay, I put the message of product, laptop, and price 1500, and I send 3 times. So it will be 3 times. The data will be sent 3 times, and we see okay. It will it so the 1500 is come to the first window. So the window is suddenly closed. So the data we sent 3 times, but one data is already in the first window, and then we okay. So in the second window we have 500 again, and so yeah. Okay. Yeah, that's basically okay. It should be 1500 times 3, 4500. We got 1500 two times. Okay, no worries. But yeah, that's basically the aggregation. It will be summing up. We move to the next one for join. So join, we have two uh, sources, and we want to streaming sources, and we want to join together and output and return the single result. So okay, so this is the first PubSub message. Well, scroll down. Oh, okay. It's being hidden. Okay, this is the second one. I need to join. Okay, I will stop this and run the join Apache Beam pipeline. I want to join this two data, student ID and the name to the first PubSub message, and the second one is student ID and GPA. Okay, I want to join by using student ID. together. Hopefully, it comes to the same window so we can join there together. Okay, just wait. I set the window by 10 seconds and then 10 seconds for the second pops up. So just wait for 10 seconds. Okay, come on. Maybe delayed because of the network. I don't know. Come on.
So it should be merged, right?
Yeah, yes, join. So there are two softwares with the same key student ID, and the idea is to
So
show.
the first to be published will be top one.
No, basically because we have the same window. So the first, that's okay. It's being delayed more than a second. So the result is I have student ID one and name and GPA in the same output. So meaning the two sources is coming to the same window. And after 10 seconds, the window is closed, and then the join process will happen. So I get and GPA with in a single output rather than in the different outputs. So that's how the join operations happen in Apache Beam. And this is the code. We using we are using code group by key to join two sources into a single Pycon. Okay, and the last demo I have is okay, chatbot based calculator. Basically, I create a chatbot web based and I input number to the chat, and I'm using session window. So, I'm, before I end the input, the windows will be open. After I have the inactivity of the input, so the window will be closed and it will continue the process. Okay, let's stop this pipeline and uh, run the. Okay, this is the first script. Okay, so let's start the Apache Beam for chatbot, and I input the value. For example, 10, 10, 10, 10, 10, 50. So until I don't put any input, the window will still be open. Okay, so I stop, and then shipping will wait for 10 seconds for inactivity, and if there is no other activity, it will process the output. So it will be summing up all of the numbers that I have input. Okay, let's wait. It will be show up in the left. Okay, total number you input is 294. Yeah. Okay, so back to the presentation. I have 6 minutes left. Alright. So yeah. In conclusion, by using Apache Beam, we can have the flexible way to process batch and streaming. Even though in this session I focus on the streaming pipeline, and also we by using Apache Beam, we reducing the complexity of maintaining separate pipelines. So instead of having two components, two frameworks, we just using single framework to do both. And by using Apache Beam, we can have the streaming code more simpler and more efficient to work with the real-time analytics or transformation of large scale batch and maybe a streaming job. So, okay, that's all for my session. Thank you. And you can find out the presentation slide on that link and the source code of the previous demo is also I have pushed into my GitHub repository. And then this is QR, you can find my contact and let's stay connected after this session. So, thank you very much. Good afternoon.
Thank you.